Good morning, good morning. Let's start yet another developer log. Yesterday I reached out to, I think the exercise 40 was the one. Let's confirm it. Yeah, let's go to the 41. The tricky part is that the pointer's mutability, var versus const, refers to the ability to change what the pointer points to, not the ability to change the value at that location. Yes, of course, this doesn't make much sense otherwise, right? The whole point of pointers is, yeah, to my understanding, is to be used within the functions, because by default the parameters that you pass to the functions are immutable. So if you pass a pointer to a function, you're able to change its value, but not the location of the value. Okay. Uh, Both p1 and p2 point to the constant values which cannot change. However, p2 can be changed to point to something else and p1 cannot. Okay. So here p3 and p4 both can be used to change the value they point to, but p3 cannot point to anything else. Yes, because p3 itself is a constant, even though what it points to is a variable. What's interesting is that p5 and p6 act like p1 and p2, but point to the value at unlocked. This is what we mean when we say that we can make a constant reference to any value. So what we are doing here is similar to p1, but we neither can change the value nor the pointer. Here we can change pointer to point to something else. Okay, so what is the error here? We have a compilation error, expected a semicolon. Okay, please define the pointer p so that it can point to either foo or bar and change the value it points to. Set either value, either foo or bar. And then change the value. Okay, so it's using undefined. I'm setting it to var, so I'm future it's going to be assigned to. And then it's a pointer to change the value as well, like dereferencing it and adding a value, so I'm not using a constant pointer. Good. Number 41 solved. Let's go to 42. Now let's use pointers to do something we haven't been able to do before. pass a value by reference to a function. This is what I was talking about in the previous exercise. Why would we wish to pass a pointer to an integer variable rather than the integer value itself? Because then we are allowed to change the value of the variable. Pass by reference when you want to change the pointed to value, otherwise pass by the value. Yeah. One thing I learned yesterday is that Zig will optimize how it's going to treat the parameters that you're passing to your function based on the situation. So it decides for the best optimized way to treat the parameters with. However, being it passed by reference or passed by value, in either case, the parameter itself is immutable, and that's why how the optimization can happen. And thus, if you use pointers, basically that's where the pointers become handy. So what is the error here? Expected, yeah, the question mark is the error down here. Make 5. Fix me. Okay, the idea here is to set the value. It's a pointer. X itself cannot change too, but its value can be changed. So I think this should be like this. So we dereference it, set the new value for it, and then click build. Nice. And with integers, you can pass a pointer to a struct when you will wish to modify that struct. Pointers are also useful when you need to store a reference to a struct, a link to it. Okay. We have a struct called vertex, and then we initialize it in v1, and then we have a pointer to it. Note that we don't need to dereference pv pointer to access the struct fields. Okay. We can write functions that take pointers to struct as arguments. This function modifies the struct v. And call them like so. Let's revisit our RPG example and make a print character functions that takes a character by reference and prints it and prints a linked mentor character if there is one. Okay, this is similar to before. Then we have a character, a struct. You can provide default values. Oh, okay, this is new. So when we define a struct, we can set the default values for it. I need to use the question mark here to allow for a null value, but I don't explain it until later. I think this means optional. So, but that's why you can set it to null. Okay, please don't tell anyone. Okay. Pub fn main void, yeah, and then we have mighty corridor, yes, and then glarp, and then fix me. Okay. Now down here we have a print character. Oh, this is a reference to itself, so another character can be a mentor. And then, yeah, here we expect it to be a pointer, then we glorp. That's it to be a pointer. I think this should solve. Man, yeah. Yeah, 43 also solved. Now let's go to 44. Elephants walking along the trails are holding hands by holding tails. From Holding Hands by Lenore Emlich. Okay. We have an elephant struct. Letter tail. So we have a linked list as elephant holding tails. Yeah. And then the error use of undeclared identifier elephant B. Okay, and it should be elephant B elephant dot letter B. And now link the elephants so each tail points to the next elephant. They make a circle. A to B, B to C, C to A. And then elephant B, the tail to elephant B. This function visits all the elephants once, starting with the first elephant and following the tails to the next. If we didn't mark an elephant, this will be, yeah, we need to mark them one by one. And then visited true while not visited. Yeah. Beautiful. Sometimes you know that a variable might hold a value or it might not. Zig has a neat way of expressing this idea called optionals. An optional type just has a question mark like this. And just like I guessed. An optional type, yeah. And then now foo can store a U32 integer or null, a value storing the cosmic horror of a value not existing. Yeah. Before we can use the optional value as a non-null type, a U32 integer in this case, we need to guarantee that it isn't null. One way to do this is to threaten it with the or else. Okay, here bar will either equal to U32 integer value stored in foo, or it will equal to 2 if foo was null. Before we use, what does it mean? Does it mean that if we end up having a value, a null value, and try to use it, compiler will raise an error? Okay, let's see for that. What does it say? Expected type U8 found. Oh yeah, then that's it. So now I'm setting the result, getting the result of a U8, which is returning null. So here I would say result or else 42. No, 46. Now that we have optional types, we can apply them to a struct. The last time we checked in with our elephants, we had to link all 3 of them together in a circle so that the last tail linked to the first elephant. This is because we had no concept of a tail that didn't point to another elephant. We also introduced the handy question mark shortcut. It is okay, so if I put that question mark, it should say the case shouldn't ever happen. Check out where we use this shortcuts below to change the control flow based on if an optional value exists. Now let's make those elephants tails optional. So this is now optional, and then we have link elephants so that each tail points to the next. Link elephants will stop the program if you try and link an elephant that doesn't exist. Uncomment and see what happens. For this at point is fine. Link elephant is basically setting the tail, and to set the tail, we are using question mark, meaning it should be undefined if something doesn't exist. Okay, but before that, let's actually fix this error, the visited elephant. Or else break. Terminated unexpectedly. Ziglings hint elephants again. Not much of a helpful error. Is it because of this? will stop the program if you try and link an elephant that doesn't exist. Comment and see what happens below. This is kind of scary. This error is not showing much to me. Oh, wife was 36. I'm at 46. Oh, okay. Now I see. Yeah, now when I use run, it shows a better error. It's indicating that attempt to use null value e2 dot question mark. And then I have a stack trace. Says in the linked elephants to missing elephant in the run main. This is basically the error. Okay. Number 46 solved. Let's go for 47. Help. Evil alien creatures have hidden eggs all over the earth and they are starting to hatch. Before you jump into battle, you'll need to know three things. 1. You can attach functions to structs and other type definitions. This also yesterday I learned from the book. Basically you need to define functions as public, just like public classes in other programming languages. This kinda enables us to also have some object orientation available. You can define init function as well. A function that is a member of a struct is namespace within the struct and is called by specifying the namespace and then using the dot syntax. Yes, the neat feature of these functions is that if their first argument is an instance of a struct itself or a pointer to it, then we can use the instance as the namespace instead of the type. Yeah, so we can have a self. The difference between having a pointer or the value itself is using pointers. Again, just we learned we can change the state of the class, or yeah, just have access to the values. And notice that the name of the parameter doesn't matter. Some use self, other use a lowercase version of the type name, but feel free. I think for me the self would be the style I use, just to make it close to my beloved Python. This is more JavaScript. Okay, this also is fine, but yeah, self reads better in my opinion. And then look at this hideous alien struct. Know your enemy. We have an alien, we have a house, we have hatch. We hate this method, okay? And then hatch takes an strengths, returns an alien. Oh, it returns a new alien. And then okay, it sets its health to 5 times its strength. Your trusty weapon zap those aliens. We have a hit ray, it has a damage. When we zap an alien, we set its health. Health, self damage. Okay, so basically if the damage is higher than alien's health, we set it to 0, otherwise subtract it from the damage of the hit ray. This is fun. Let's reveal to see the error. Okay, there are some question marks, of course. We have aliens hatched. This hatch method is like an init method. Returns a new instance of the class. Where aliens alive. Yeah, the number of them, and then we have a hit ray with damage of 7. We've been given a hit ray weapon. Yeah, we'll keep checking to see if we've killed all the aliens yet. Yeah, look through every alien by reference. The pointer capture value, and then zap those aliens. Heat ray, and then zap. What was the inputs? Yeah, thank you. The self is going to be passed directly, and then we put alien here. But there we need a pointer. I think this works, right? Because here the alien itself is a pointer, then yeah, if the alien's health is still above 0, this is still alive. Changing the value of the loop inside the loop. Okay, isn't it dangerous? Okay, now alien health. I think this will work, right? But my question is why we are increasing it. 5 aliens, 4 aliens, 1 aliens, 0 aliens. Every time we come inside the loop, we are setting it to 0. That's why I missed this line. I thought this is the reference value. And we are only setting this for this start part. I'm wondering even if we need this loop outside here. Probably not. I mean like this, right? We could just set it to true and then start with this. This would have been undefined. That's the style that, yeah, they're preventing to use undefined, right? So good. Okay, number 47 also solved. And then let's go to 48. Now that we've seen how methods works, let's see if we can help our elephants out a bit more with some elephant methods. Okay, and then we have elephant, we have get tail. Remember, this means or else unreachable. Has tail, self tail is not equal to null. Okay, so basically to run this method we need to first run this and then visit true, and then prints elephant's letter and visit it. Okay, this is easy. And then we have our elephants, we chain them together. Basically, what was it saying? Holding hands using their tails. And then this function visits all elephants once, starting with the first elephant. And then here is the error. This gets the next elephant or stops. Which method do we want to hear? Pass tail, get tail, or back? Zig build. Yeah, this is solved. Ziglings can also have methods. This comment originally asked if anyone could find instances of enum methods in the wild. The first 5 pull requests were accepted, and let's see. Enums with methods. We have a file extension, Ziglings support, Ziglings supports dep file, return. Okay. Oh, this is, yeah, it's a helper method that provides some dynamic information on the file extension, and it basically takes in the file extension itself. Based on that, it has a switch statement basically saying if it's a C, then true. Okay. Yeah, this is totally fine. Found many. Here's one. Love this language so far. Me too. And then here's another enum method. Yeah. Let's go for number 49. Trunks and tails are handy things. Now that we have tails all figured out, can you implement trunks? Okay, we have elephants. What methods do we need? Visit elephants while true. Hash trunks, get trunk. So we say pub fn has Is it has trunks as plural? No, trunk. Okay, has trunk itself, and then elephant. This should be bull, and here return self that trunk not equal to null. It's similar, right? And then pop and get trunk self star elephant, and then star elephant. And then return self that elephant self that trunk. The trunk can never happen. Is it possible to write it safer? I'm going to try that, but let's first build it. Yeah, 49 solved. But here I could say fn get trunk safe, let's say, then self elephant star elephant. You cannot, right? Because you either need to trunk, or else here you need to either provide imaginary elephant or null, right? And if you do null here, it should be like this. Okay. $49 also solved. Let's go 50. We live on a placid island of ignorance in the midst of black seas of infinity, and it was not meant that we should voyage far. Okay, Zig has at least 4 ways of expressing no values: undefined, null, error, and void. Undefined should not be thought of as a value, but as a way of telling the compiler that you are not assigning a value yet. Any type may be set to undefined, but attempting to read or use it always is a mistake, and it will raise an error, right? And then null. The null primitive value is a value that means no value. This is typically used with optional types, as with the question mark UH shown above. When foo equals null, that's not a value of type U8. It means there is no value of type U8 at all here. And then when using it, you need to make sure you have or else, right? Just like we saw, errors are very similar to nulls. They are a value, but they usually indicate that the real value you were looking for doesn't exist. Instead, you have an error. The example error union type of my error, it means that Foo either holds a U8 or an error. Yeah, that you learned. There is no value of type U8 in foo when it's set to error. Yes, void is a type, not a value. It is most popular of the 0-bit types, those types which take up absolutely no space and have only a semantic value. When compiled to executable code, 0-bit types generate no code at all. The above example shows a variable foo of type void, which is assigned to the value of an empty expression. It's much more common to see void as the return type of a function that returns nothing. Zig has all of these ways of expressing different types of no value because they each serve a purpose. Briefly, there is no value yet. This cannot be read yet. There is no explicit value of no value. Okay, there is an explicit value of no value. There is no value because something went wrong. There will never be a value stored here. Please use the correct no value for each question mark to make the program print out a cursed code from Necronomicon. Okay, if you're there. Hi there. So, first one. First line. What are we doing here? It's an array. Okay, this is undefined. Here we either have an error error that, yeah, and here we don't return anything, and here is null. Easy. Okay, that's enough for today. Please like and subscribe if you like, and see you next time. Enjoy.